Now what we are going to do, we have studied what is horizontal curve, we have studied what is vertical curve. Okay. Now, in some cases, a horizontal curve and a vertical curve may come together. Which all portions? Maybe it's a hilly area. Okay. Many of you might have living in some hilly areas. Like I told you, I was recently in Uttarakhand. So when I was going there, all the road is how? It will be something like this. It's a hilly area, that area where I went. Okay. So if you want to go from this location to this location, let it be. Okay. There may be something, some town there. From here to there you want to go. How we will be making a road? See, either we have to make a tunnel through the hill. But if it is a very large hill, making that much kilometers of tunnel is not possible, right? Construction cost is that much, and also we cannot make that much kilometers of tunnel and all, no? Very difficult. So what generally we used to do, we may be making roads like this. Something we'll go back, we'll come again we'll come here like this, again we'll go back, we'll come, and again we'll go like this, again we'll come. Like this we are going to make the road, na? Like this. Understanding what I have drawn? See here, which all things you are doing? You are going upward. Are you going upward? Yes. Which means it's a vertical portion. In such cases, are you going to turn your steering? Yes. Which means there is a horizontal curve portion. So it's a combination of horizontal curve and a vertical curve. Correct, na? So in such cases, what is the problem? Definitely if it is a vertical curve, some resistance is going to happen on your vehicle, na? There is a component of weight towards downward, correct, na? So on a vertical curve, if you are traveling on a vertical portion, definitely there is some opposite force who is pulling you backward. Your vehicle will not be getting that much pulling as much you are getting on a straight road. Whenever you are going upward, definitely you will not be getting that much pulling for your vehicle, right? So there is a resistance on the vertical curve. Whenever you are turning the vehicle on a curve, there is a resistance on a horizontal curve also. Okay? Actually speaking, not that much important, but you can note it down. If I am drawing simply one curve, this is a straight line, straight road, and here there is a curve. Okay? Suppose your vehicle is traveling on a straight road, it is having some pulling force or tractive force, some P. Okay, pulling force or tractive force I can tell. And this is your straight road line, na? This is your line of action, or this is your direction of straight road. So whenever you are reaching on the curve, what you will do? You are going to turn your steering. So now your pulling force is this. Okay, this is on the straight road. This is the pulling force on the horizontal curve. It is found that approximately, suppose how much turning you have done. Suppose this is some theta turning you have done. If this pulling force is something P, this pulling force will be P into cos theta. What it means, if you are going straight, theta is equal to 0. 0 means cos theta equal to 1. So you will be getting the exact tractive force. Okay, if I am simply putting this as P. If you are turning little bit angled, then theta value is going to be changed. Okay, so P cos theta also will change. It will not be 90 degree, na? Which means it's not a curve, it is a sharp turn. It's another straight road. So some resistance is going to happen because of the curve. Okay, and this is what? This is some reduced pulling force or reduced tractive force. You can also note down these things in the side or somewhere just for your understanding. Okay, some reduced tractive force. This was the original pulling force or tractive force, but on the curve some reduced tractive force is there. Okay, this phenomena I can call it as something curve resistance is there. Curve resistance. So how much is the curve resistance actually? That decrease. The P minus, what is this curve resistance? P minus P cos theta, I can call it as the curve resistance, just for your information. I was having P, but now I am having P cos theta. Why it got reduced? It is reduced because of the resistance which is happening on the curve. Resistance in pulling force. Some effect is there, na? So IRC has simply formulated one equation. It will be approximately equal to P cos theta, like that. Okay, no need to go deep. Simply I want to tell you there is some effect on the horizontal curve as well as on the vertical curve. So whenever some horizontal curve is coming, definitely our speed we have to reduce. Whenever we are going on a vertical curve, definitely there also our speed will get reduced because there is a component of weight downward. Correct, na? So in such portion where a horizontal curve is coming along with a vertical curve, our vehicle will get some increased resistance. You might have already experienced, na? If you have driven your vehicle on such roads, it will be very difficult to climb such a hill. You may have to give more acceleration and all. Correct, na? Because of that, what IRC told that, suppose this gradient, there is a maximum value for that gradient or that slope. That slope is called as rolling gradient. Rolling, the word rolling means it is something designed. Okay, rolling in the sense it is designed. So rolling gradient means for what gradient we are going to design it, which means that is the maximum value of slope a vertical curve can attain. Okay, that can be the maximum slope. It shouldn't be more than that. If it is more than the rolling gradient, what is the problem? If it is more than the rolling gradient, the vehicle cannot climb. The vehicle will stop there. Okay. So whenever a horizontal curve is coming, along with the vertical gradient, finally what may happen? The resistance or the resistance your vehicle may be getting is very high. You may not be able to climb, you may not be able to go through the roads. Okay. So I told you the maximum value is rolling gradient. But along with that gradient, there is a horizontal curve is also coming, which means we cannot give this maximum value. We have to reduce it. Understanding? Theoretically speaking, maximum value of vertical gradient we can call it as rolling gradient. But along with that rolling gradient or along with that vertical curve, if a horizontal curve is also coming, then you are getting some extra increased resistance. These things also will come along with that vertical curve resistance. Okay, which means we cannot give that much vertical gradient because our total resistance is too much. So we have to reduce the gradient, the existing gradient, we have to reduce it. Okay, such process is called as grade compensation. So first you write the heading grade compensation. I'll just give you some 2 sentences to write there. Write the heading grade compensation. You can write some sentence there. When a horizontal curve, grade compensation, when a horizontal curve is coming along with a vertical curve, when a horizontal curve is coming along with a vertical curve, vehicles will experience increased resistance. Vehicles will experience increased resistance or a very high resistance. Resistance means what? Resistance for the movement. Okay. Vehicles will experience a very high resistance for the movement. That's it. So, the vertical gradient of the curve, or simply, so the gradient of the vertical curve has to be decreased. So, the gradient of the vertical curve has to be decreased. Okay? It is called as grade compensation. It is called as grade compensation. Whenever a horizontal curve is coming along with a vertical curve, the vehicles will experience a very high resistance. So, in such a case, the gradient of the vertical curve is to be decreased. It is called as grade compensation. Written? So, there is an equation for grade compensation. What is that? How much we are going to decrease. Okay. So, there is an equation for grade compensation given by IRC. Simple equation. Two equations are there. Whichever value we are going to get minimum, that is our final value. Okay. So first value is 30 plus R divided by R. That much percentage. Directly we are getting some value. It is in percentage. Okay. The second value is 75 by R. You might have already studied in college, na? 30 plus R, maybe some syllabus it may be there. 30 plus R by R percentage or 75 by R percentage. What is this R? This R is nothing but the radius of curve. Radius of the horizontal curve. Okay. Radius of horizontal curve. There is a horizontal curve coming now. So depends on the radius of the curve, horizontal curve coming along with the vertical curve. We are going to calculate the grade compensation. What do you mean by this grade compensation? It is nothing but the reduction that we are giving. Reduction on actual gradient. Reduction on actual gradient or reduction on existing gradient. Okay. The reduction that we are going to give is called as grade compensation. Okay. So that much reduction we are going to give, which means from the actual gradient, whatever be the actual gradient, we are going to minus some value or we are going to decrease that value. What is that value? We call it as grade compensation. Correct now? After calculating from the existing value or from the actual value, we are going to minus that value. That's what it is called as a reduction. So what we'll get? We'll get a resultant gradient. The result of this calculation, we call it as compensated gradient. Compensated gradient. What do you mean by compensated gradient? The result of your calculation. Means first you are going to calculate, it is called as grade compensation. So simply put GC, which means it is grade compensation. Okay, simply for writing purpose I put it like that. So after calculating this, in the question they might have either they can ask you grade compensation is how much, or they can ask you what is compensated gradient. So if they are asking grade compensation, we are going to calculate that and we are going to take the minimum value. Okay. In case if they have given some actual gradient or existing gradient or something ruling gradient, then they are asking what is the compensated gradient, which means from the actual gradient we have to minus whatever value we got here, and that result value we call it as compensated gradient. Okay. Say I told you whatever we are getting for grade compensation is in percentage. Directly we are getting in percentage, na? Which means the actual gradient also we may have to convert into percentage. So the compensated gradient also we may be getting in percentage. Correct, na? So properly we have to substitute and take the minus value. I mean, in case I told you slope I can express in various forms. 1 in 100. If they are giving in 1 in 100, which means it is 1%. You have to convert into percentage. I can tell the same thing in 1 by 100, that is also same. Or they can express directly in percentage, that is also same. Or they can tell it as 0.01, that is also same. So in whichever form they are giving you the existing gradient, first we have to make it into the percentage form, then we have to put this equation. Why? Because directly we are getting in percentage here. So from a percentage value only I can minus another percentage. Understanding? Okay. So note down these things. Either they can ask you this or this. Okay. Now, while calculating this thing, the compensated gradient, there is a very important rule. IRC told a rule here. What is that rule now? Whenever you are minusing this value from the existing value, you are going to get a result which we call it as compensated gradient. IRC told that after minusing, your minimum value should be equal to 4%. Your minimum value should be equal to 4%. If you are minusing and you are getting some 3% and all, you shouldn't take it as 3. The minimum value is 4%. In super elevation, we told some maximum limit 7%. Correct, na? Whenever we were getting more than 7%, the final answer we were giving as 7% like that here. After minusing, if you are getting something less than 4, you have to put it as 4 only. Your gradient shouldn't be less than 4%. So minimum slope should be there. Okay, what is that 4% means? Some minimum slope should be there. Otherwise, if the slope is very less, what happen? The road length is going to be increased like anything. Finally, you have to reach here now on the top. If the slope is more, then only we can reach there fast. Then only we will reach upstairs. If the slope is very less, then again lot of curve you have to make it to reach at the top. Correct, na? And also some drainage problem may be there if you are not giving good slopes. Okay, that's why. In some questions, this rule will come. Okay, we'll see how to do it. Exactly in superelevation also we did the same thing. Whenever we were exceeding the limit, we were taking the final answer as 7%. Like that, after minusing, if you are going less than 4%, you have to set it as 4% only. Understanding? Understood the concept? Can you do the first question then? Grade compensation. Take the question. While designing a hill road with a rolling gradient of 6%. While I am explaining, don't try to do it because sometimes some point you may miss it. Okay, you'll get the time. I may be explaining lot of things. Even if the concept is simple, there is chance of making some tricky question. That's it. If the equations, everything is very complicated, then they may not be making tricky questions. But if the equation is very less, then they can easily make a tricky question. That's why. Okay. Compensated gradient they are asking, not grade compensation. Okay. Always check what they are asking. Radius is 50 meter. So 30 plus 50 by 50. And how much this is? 75 by 50. Directly you are going to get it in percentage, na? How much will be the value? 1.6 and 1.5. So whatever you are getting, I told you it will be directly in percentage. So they have not asked us what is the grade compensation. They are asking what is the compensated gradient. Existing gradient is 6%, which means 6% minus, what is the minimum value here? 1.5. Minus 1.5%. 4.5%. See, one more step is there. What is that step? What is that step? The step is nothing but the check. The minimum value is how much? 4%. So given value, obtained value is more than that, more than the minimum limit, and that's it. That will be the final answer. Understanding everyone? Is 4% is for GC or CG? 4% is for compensated gradient. After minusing, the value should be at least 4%. Minimum is 4%. Okay. The compensated gradient, the final, after minusing what you are getting, that value is 4%. Okay. Getting very good, everyone getting now 4.5%. See, do you think this much silly question they will ask you? Huh? Do you think this much silly question they will ask you? In case if they are asking, how much mark they may be giving you? What do you think? It's a previous gate question for how many mark maybe? It's a 2 mark previous gate question. Okay. It's a 2 mark question, previous gate question. Okay. That's what you cannot expect what they are going to ask you. See, many times some tough question or lengthy question they asked for 1 mark. Many times such easy question also they asked for 2 marks. And that's the beauty of transportation. Sometimes you will get 2 marks easily. Sometimes you will get 1 mark after putting lot of effort. Sometimes. Okay. 1.5%. See, minimum value we are going to take now. Whatever be minimum. Okay, we are going to calculate 2 values. This is one equation. This is another equation. Whichever value is minimum. See, this is 1.5. This is 1.6 and 1.5. Directly we are getting in percentage. So that's what Understood, Aditya? The minimum value of two values. Understood? Okay. Suppose if the question was grade compensation, then 1.5 is the answer. Here it is compensated gradient. Then this is the answer. So always check what they are asking. Okay. Now take the next question. What will be the answer? The gradient of a high Y is 1 in 20. What all things they told? Radius is 30 meter, which means 30 plus 30 by, everyone listen, which means 60 by 30, 2%, 75 by 30, which means it is 2.5%. How much you took? You took 2%. Correct, huh? Now let's see. Let's wait. It's not C also. Let's wait. What they are asking? They are asking you the grade compensation, not compensated gradient. Listen. Now, directly you are taking 2%. Okay. IRC has given a rule. What is that rule? If you are applying some reduction, after applying the reduction, it shouldn't be less than 4%. That is the rule, now. Whether they have given any existing gradient, yes, they have given. What is that? 1 in 20. 1 in 20 means how much percentage? 1 by 20 means 5%. Correct, now? Existing gradient is 1 in 20. 1 in 20 means 1 by 20, 0.05, 5%. They have given some value, which means this value is given, now. Actual gradient is given already. What is that actual gradient? 5%. If you are minusing the 2%, how much you are getting? If you are minusing the 2%, how much you are getting? You are getting something 3%. Is it okay? It is not okay. How much it can be maximum? Sorry, minimum to minimum, how much you can reduce? You can reduce till 4% only. But are they asking you the compensated gradient? No. What they are asking? They are asking you what is this value. Tell me what can be this reduction. It cannot be 2%. Why? If you are reducing 2%, you are going to violate the rule. If you are applying 2%, if you are reducing by 2%, the compensated gradient will be less than your minimum limit. Maximum to maximum, you can decrease that 5%. There is a slope of 5%. Okay, I am having something here. Let it be this is 5%. How much I can decrease? I can decrease till it is 4%. Then how much is that decrease? How much I can decrease? How much is that decrement? Very good. Now I can reduce only 1%. Understanding? If they were asking the compensated gradient how much? Compensated gradient how much? Then it is 4%. They are asking you what is grade compensation? What will be the answer? 1%. Now tell me, was it an easy question? Your option D was correct. You understood how trickily they can make the question. This is not previous question. I was simply making it just to let you know that how many ways they can. Okay, understood now how they can make you the question. Always check it. Okay, that's what I told. It's very easy to deviate the students in easy question. If it is a tough question, definitely you will read it again. You will take all the values very carefully and substitute. But if it is an easy question, then within seconds you will solve and go. So that you shouldn't do. Okay, always check the question properly. Always go through the question neatly. Okay. See, I'm just telling it once again. Just see. I'm telling you again, this concept has not used till now. Okay. Whatever question they ask, it is very direct, easy question. So in case if they are asking such question, take it as an advantage. Okay. Now, what they are asking? They are asking you grade compensation. Easily I can find out, and I am taking the value 2%. But in the question they have given some actual gradient also, 1 in 20. In case if they are giving some actual gradient in the question, if they are not giving nothing, this is my final answer. That's it. Okay. But in case if they are giving some actual gradient, what you have to do? always you have to check what will be your compensated gradient. They are not asking you what is compensated gradient, but still you have to check it. Why you have to check it? You have to check if you are giving this much reduction, are we obeying the IRC rule or not? You got it as 2% reduction in the sense grade compensation. So if you are applying 2% grade compensation, what may happen? Existing gradient is this much, 5%, 1 in 20. So if you are applying 2%, you are going to violate the rule. After minusing, you can get only 4%. It should be minimum 4%, which means you can give only 1% reduction. Understood? Thank you. Do one thing. Just take the next question also, just for your practice again. Try to do the next question. The gradient is 1 in 18. Just tell me what is the value. So radius is 30 meter here also, na? Okay, so 30 plus 30 by again 30. So 2%. So 75 by 30, it will be 2.5%. See, suppose that 1 in 18 is not given in the question. Actual gradient is not given. Then what we can do? We cannot check it. Correct, na? If they are not giving the actual gradient, we are not able to check it. So that we are assuming that okay, the final it may be more than 4%. That's it. In case if they are giving in the question, then we have to check it. Okay, 1 in 18. 1 in 18 means how much? 1 by 18. How much 1 by 18? 1055 something it is going, which means I can take it as something 5.55%. Okay. Now, if I am applying, how much it will be? 5.55% minus 2%. How much I am getting? 3.55%. Can I give 2%? No. Which means I cannot give this value. How much I can give? 5.55 is the existing. If I am minusing something, maximum I can get 4%. If it is going below, okay? If it is above 4%, it is good. That's it. Okay? Then what can be this value? Maximum to maximum, it can be 1.5 only. Understanding now? Then it is 1.5%. Very good. Now everyone got the concept now? Okay? So after calculating the grade compensation, in case if they have given the value of existing gradient, always check it.